Okay. Synovial fluid, this is just a description of this. You can read this on your own. Just point out that synovial membrane, it has loose connective tissue and epithelial cells, synoviocytes, which produce fluid. It's an ultrafiltrate of blood plasma across the membrane. It doesn't have a lot of high molecular weight molecules in the passing from the blood into the synovial cavity, because the synoviocytes want to create their own, and they add something called mucopolysaccharide into the synovial cavity, into the synovial fluid, and that mucopolysaccharide contains hyaluronic acid and some protein as well. And hyaluronic acid is so you can do knee injections and put more pseudo synovial fluid inside the knee, and you got to get a new injection every 4 to 6 months or something like that if you're getting these knee injections. But you can put more fluid in the knee, and what they do is they put this mucopolysaccharide in there, this hyaluronic acid in there, and that hyaluronic acid holds water and makes a gel-like substance in the knee, and you get that from actually rooster combs. So you take that, and they take rooster combs and they grind those up and make the substance that you inject in your knee. Next slide. So here's the definition of hyaluronic acid. I'm not going to go through this. There's no reason to. Next slide. Synovial fluid is very viscous because it has this polymerized. It says polymer of hyaluronic acid, and a lot of times you abbreviate hyaluronic or an acid by putting ATE at the end. So hyaluronate is hyaluronic acid, and you abbreviate it because its acid is complex with some sort of ion and makes it a neutral compound. So you can get clotting of your synovial fluid if fibrinogen, which comes from blood vessels, is present. And sometimes if you get a traumatic injury to the knee or some joint, you can actually have some blood plasma get in there, and the fibrinogen clots or gets cut up into little pieces into fibrin, and you get some little fibrin pieces in there. Then that gets hard to clear out. So next slide. I'm not going to go through this it's just too detailed. Next slide. That's just a picture of hyaluronic acid and what it looks like. Next slide. It's very viscous. It's also elastic, so it has its viscoelastic properties. So now we're going to talk about the types of synovial joints based on movement. Your book talks about this. I don't like this at all, but I'm going to talk about this just because your book has it in it. I am not going to test you on this. So, but I think you probably need to have heard the words, but I think it's way too confusing. So, there's joints based on movement, and you can talk about axes of movement. So, if you have an axis of movement, and it goes up and down, so like the elbow joint is a hinge. So we're going to talk about hinge joints. So that's a uniaxial joint. It has only one, goes up and down. It doesn't go in different directions. Biaxial means that you have moving around two axes. So, and I just don't like this. Sorry. And multiaxial means so you can so in this case where the metacarpals come together, you can bend your fingers down towards the palm of your hand, and then you can raise them back up and straighten your hand out. And that was this picture here. But you can also spread your fingers apart. Okay, so that gives you a second axis at the metacarpals. And but there's also a little bit of movement. There's also some movement down at the wrist as well with the metacarpals. So I'm not entirely sure. I don't really like this definition of this stuff, but your book talks about it. So the book says there's non-axial, uniaxial, biaxial, and multiaxial joints. Next slide. So here's a multiaxial joint. Would be the shoulder joint. It can go in all kinds of different directions. So you can go back and forth. You can go up and down, and then you can actually rotate externally and internally rotate. the shoulder. Next slide. This is more commonly how you divide up the synovial joints based on planar, hinge, pivot, condyloid, saddle, and ball and socket. So planar, hinge, pivot, condyloid, saddle, ball and socket. The planar joints are two flat surfaces coming together and gliding across each other. Hinge joint would be the elbow and knee. They flex and they extend. So the elbow, you can flex it, which means you bring the forearm towards your upper arm, and you extend it by making your arm into a straight line. Same thing, similarly for the knee. Pivot joint, the atlantoaxial joint, the dens, also the proximal radial ulnar joint. You know, the radius has that round head on it, so it can pivots around a central axis. Condyloid joint is a metacarpal phalangeal joint. It's not a ball joint. It's more of an oval. You can't get rotation, but you get flexion. You get lots of different movements around it. Saddle joint, there's only really one of those. There's a couple of those that are that. Carpal, the trapezium, also metacarpal 1. But those are essentially condyloid joints. And then the ball and socket joint, shoulder and hip. So you get all kinds of different movement called flexion, extension, abduction, adduction, circumduction, and rotation. We're going to talk about what those are also. Next slide. So here's just a summary slide of all those of the different types of movement. Next slide. Looking at the gliding motion that occurs when you have two bones glide across each other's surfaces. So you have articular cartilage and the planar surfaces. They're fairly flat surfaces. Next slide. Synovial joints. You have the planar joint here, A, B, a hinge joint. Show an example of the elbow there, elbow. And then a pivot joint, C. So the dens on this is C2, C1. And then we have condylar joint. So where the distal end of the metacarpals touching the proximal end of the proximal phalange there. So you have this. So we have this like rounded edge condyloid, a rounded edge sliding against a concave surface. A saddle joint is a little bit deeper, basically, than the condyloid joint. And then we have a ball and socket joint, which can rotate and spin around all kinds of different directions. Next slide. So here's just a summary of all the joints and movement and what each of these joints can do. You don't have to know this for the test. Next slide. And just another, I put this together. You don't have to know this for the test either. Next slide. There's a summary slide of all types of movement. Next slide. Oh, except for the fact that, point out, down here at Lumen Learning, I'll probably pull some stuff from them. They actually have some good stuff, so we'll have some course material from them later on this semester. Next slide. So, the major categories of synovial joint movements are gliding, angular rotation, and special. And we're going to look at those. Next slide. So gliding, you have the flat surfaces, the planar surfaces, planar joints. Angular, you have flexion, extension, hyperextension, abduction, adduction, circumduction. Then you can rotate. And then you have special joint movements, elevation, depression, protraction, retraction, supination, pronation, inversion, eversion, dorsiflexion, and plantar flexion. And we're going to go through what each of those is. So, and you get to actually do these on your own body, so you'll need to know all these. I'm not going to ask you the definitions, but if you see a picture of them, you need to know what it is. Next slide.